Hey guys, we're going to start the new section on bisectors and triangles on textbook page 301. Alright, the first part, just forewarning you guys, there's a lot of vocabulary in this section and a lot of new terms with those vocabulary words. Okay, so the first one is when three or more lines intersect at one point, they are known to be concurrent. And the point at which they intersect is called the point of concurrency. So just take a second to think about this. It's three lines intersecting at one point. Those three lines are concurrent. The point where those three lines intersect is called the point of concurrency. Now we're going to take a look at this example with perpendicular bisectors. We're going to do perpendicular bisectors and angle bisectors today. So concurrency for perpendicular bisectors. The perpendicular bisectors of the sides of a triangle are concurrent at a point that is equidistant from the vertices. So I have a triangle made here. I have a perpendicular bisector for line AB, perpendicular bisector for line AC, and perpendicular bisector for BC. Those three lines moving up are going to all meet at a point labeled P. P got written over with, sorry. And they're all perpendicular bisectors because they're cutting each one of these into different parts. So P is the point of concurrency, while XP, YP, and ZP are the concurrent lines. So if those three lines are concurrent, then AP, BP, and CP are all going to be equal to each other. This point P is going to be called the circumcenter of the triangle. So the point of the perpendicular bisectors of a triangle is called the circumcenter. So where these perpendicular bisectors meet is the circumcenter. Each one of these different concurrent lines are going to have a different vocab word for it. So perpendicular bisectors goes with circumcenter. Angle bisectors will go with something else. Medians will go with something else. So each one of these has a different vocab term. So it can get quite confusing. So just kind of take time to memorize which ones are going with which one. Okay, so since we have the perpendicular bisectors PX, PY, and PZ, and they're all concurrent at P, then PA, PB, and PC are all going to be congruent, or not, equal to each other. Alright, we're going to take a couple more things with this. So, okay, so now that we can know that the circumcenter is going to be equidistant from the vertices, we can use that fact for something else. We can use that circumcenter to draw a circle around the triangle. Since that these points are all going to be equal distance, this could be the center, and then you could draw a circle around this center point with these PA, PC, and PB being the radiuses, the radii. So because that these are all equal, this could be the center of a circle, and then you could say that the circle is circumscribed about the triangle. A couple more facts about circumcenters. When you have acute triangles, the circumcenter will be inside the triangle. If you have a right triangle, the circumcenter is on the right triangle. The circumcenter is actually on the hypotenuse here. And then when they're obtuse, the circumcenter is going to be on the outside of the triangle. So this is also something that you should try and recognize when they're acute, inside, right, on, obtuse, outside. Now we're going to go through some examples with this. Okay, for this example it says, what are the coordinates of the circumcenter of the triangle with vertices A, B, 2, 7, B, 10, 7, and C, 10, 3. Now I'm not going to draw this one on a graph, but please do notice that for two of the points, we have 7 and 7. So that means that the y value doesn't change, and for another two of the points, 10 and 10, so that means the x value is not going to change. So that kind of helps us with this. Okay, so There are a couple steps we need to do in order to figure out where this is, but to find the intersection of the circumcenter, all you need to do is find the intersection of two of the perpendicular bisectors. So all you need to do two, and the third one will have to be the same. So first, we need to find the midpoint of AB. So the midpoint of this would be 2 plus 10 divided by 2, 7 plus 7 divided by 2. So it's 12 over 2 and 14 over 2, which is just 6 over 7. So the midpoint of AB is going to be at 6, 7. Then what we need to do is we need to find the line that is perpendicular to AB and at point 6, 7. So remember what we need to do to find perpendicular points. We need to find the slope. So the slope of AB is 0. This means that it is a horizontal line at y equals 7. So there's no slope, so there's a horizontal line. So that means the point where it's going to be perpendicular to 6, 7 at line y equals 7 is a vertical line at x equals 6. Since it's a horizontal line like this at 7, and we're looking at the point 6, 7, it's going to be a vertical line here going up and down. So we found the perpendicular line at the midpoint, which is just 6. Then we find the midpoint of BC. I chose BC, you could have chosen AC, it really doesn't matter. I chose BC because I saw 10 and 10 and I knew it would be easier. So the midpoint of BC would be 10 plus 10 divided by 2, 7 plus 3 divided by 2, which is just 10, 5. Then we find the line that is perpendicular to BC at 10, 5. Slope of BC, 10 minus 10 over, 3 minus 7 and 10 minus 10 will just be a undefined. So it's a vertical line at x equals 10 because we're dividing by 0. So the perpendicular line at 10, 5 is going to be 1, 5 is going to be y equals 5. So we have the vertical line 10 and we're at the point 10, 5. So the vertical line, the line y equals 5 horizontal line would be perpendicular to the line 10. So now we have our 2 points. So let's find the intersection of those points. Well, it's just where those 2 points meet, which would be 6 and 5. X equals 6 and y equals 5. So the circumcenter is going to be at 6, 5. So when we're looking for coordinates of circumcenter, all you need to do is find 2 of them. It'd be easier to draw it out. I know because I have 2 sets of lines that are horizontal. I have a line that it's going to be vertical, highlights horizontal. I know that this triangle is going to be a right triangle from this from these coordinates if I were to draw it out. All right, let's go into the next thing, which is going to be for angle bisectors. Okay, now we're going on to the concurrency of angle bisectors theorem. So the bisectors of the angles of a triangle are concurrent at a point equidistant from the sides of the triangles. So where these concurrent lines meet, that point will be the same distance from each of the different sides of the triangle. Okay, so we have our triangle here, and we have our 3 angle bisectors because they're bisecting each one of these angles, and they're meeting at this point P. So this point P is going to be the same distance to each one of these sides. Now they're also going to be perpendicular, but they're not going to be the perpendicular bisector. They are still perpendicular, but they're not perpendicular bisector. That's something you should realize. Okay, so angle bisectors AP, BP, and CP are concurrent at P. P is the point of concurrency. So that means that PX, PY, and PZ are all going to be equal to each other. The point of concurrency of an angle bisector is called the incenter of the triangle. So this point P for angle bisectors is called the incenter. Easy way to remember that is that the incenter is always acute, obtuse, right? There's always going to be in the inside of the triangle. It doesn't really matter because it's always going to be the angle bisectors going on the inside. Then we have this point here. So a circle on the inside, inscribed inside the triangle here. So if we have these, since we have these lines that are equidistant with our in-center point here, then you can draw a circle with P, the in-center, being subscribed inside of the triangle. So when a circle is inscribed in, it's called inscribed in the triangle. So if a circle is drawn on the inside, it's on the inscribed in the triangle. So this is my in-center point, and Py, Pz, Px being my radius is for this triangle. Alright, we're going to go through one example problem, and that will be it for today. Okay, so we're given that Qn equals 5x plus 36 and Qm equals 2x plus 51. What is Qo? We're given this picture as well. So I noticed that this line here, QL, is an angle bisector. This line here, QK, is also an angle bisector. So these 2 points are meeting at one point. That means JQ, if it came out, it would still meet at this point. So that means Q must be the incenter of this triangle. So, and then I noticed that QO, QN, and QM are all perpendicular to the different sides of the triangle. So since that these are perpendicular and we have angle bisectors, these QO, QN, and QM are equidistant to the different sides, and they're all going to be equal. Since they're all equal to each other, I can set these two things being equal and solve for x. So I have 5x plus 36 equals 2x plus 51. I subtract 2x on both sides, and I subtract 36 on both sides. From here, I get that 3x equals 15, and then I divide it by 3 on both sides, and I get x is equal to 5. Now, but I need to know what QO is, but I don't have an equation for it. But I know that QM is equal to QO, or QN equals QO. It doesn't matter which one I use. So I'm going to plug in 5 for that. So I put 2 times 5 plus 51 is equal to 61. So 61 is what is equal to QO. Alright, so in class, we're going to go through some more work with this, trying to get used to all these new vocabulary terms.